This podcast is brought to you by LMU Munich.
Thanks, folks, for coming. Good afternoon. This is PyCon Web, and it's been a tremendous conference. Thanks to all the organizers. Thanks for everybody to attend and give this very first time this conference is happening. Make it so great. So what Florian and I want to talk today about is the security process we have in Django, how that might be adoptable for you or for your projects, and then also look a bit into Django's history. This talk was initially planned for 45 minutes. We got 30, so let's get started. I'm Markus Holtermann. I'm a Django core developer since 2015, and I work at a company called LaterPay in Munich, where we do micropayments.
Hey, I'm Florian. I'm also a Django core developer, and I work as a system administrator and C++ developer at a company called BAP in Austria. So what's Django's security policy? First and foremost, you have to look into this link, which will basically describe most of what we are saying here, but we will also describe some stuff in more detail. So security in Django, we take it seriously, and we have at every time 4 releases which are under active support. Most boringly is the master branch, which sees obviously every commit and also obviously every security commit. Aside from that, we have 2 short-term support releases which are under support and receive security patches and partially bug fixes. As for bigger and larger companies, we also have a long-term support release. We are currently in the process of migrating from 1.8 as long-term support release to 1.11, which will then be supported for at least 3 years and will get bug fixes and security fixes throughout that period. So, Django's security report and release process. Now that we know what versions are supported, we want to look into how a security issue is found and reported. What we are presenting here is something that worked for us, for Django itself, but we think it is useful enough to use in other open source projects too. First off, get a security mailing list. Provide clear instructions. In our case, it's on djangoproject.com/security, which links to the URL I've been showing before, where you see where you can write to. This list is monitored by roughly 10 people, and in general we try to respond within a day. We don't have any paid staff on it, so it might be that you don't get an answer. In that case, please don't just send us a new email and ask for an answer. It is not considered rude to write to a security mailing list in daily intervals if you don't get any answer, but this should really be the exception. Usually you will get an acknowledgement in 1 or 2 hours depending on time zones. We try to cover everything from Australia to the United States, so we are in a pretty good position there, I think. More importantly, after you told us that there is a security issue or that you think there is a security issue, please don't talk to anyone else. We need time to first verify and then kick off the whole rest of the process. And if you talk to someone else and they make the issue public, you put a lot of pressure on us and other companies. I've been saying a lot of we. When I say we, I mean the security team of Django itself and not Markus and me, but I think that's evident. So what happens once we got a security email? We try to assess the issue, and you will be included into the discussion. This has 2 benefits. First off, the more eyes the better usually, but since it's a security issue, we try to keep the scope relatively closed. But still, it happens that we don't understand what you're proposing in the first email, and we will ask for clarification or also ask for an exploit, or if we really have no idea what you're talking about. The next step is then to fix the issue, which is partially hard, partially easy, but we will ask you as a reporter if you want to supply a patch. In the best case scenario, you already submitted a patch with your first email. This is obviously not a hard requirement. We just will ask you if you want to work with us on the patch or if you don't have the time and we should do it on our own. Fixing a security issue is usually easier than fixing a normal bug in the sense that we are allowed to break backwards compatibility. And while Django itself tries really, really hard to stay backwards compatible, for security issues we will throw backwards compatibility concerns out of the window. The main idea here is obviously that it's more important to have a safe Django version than have a stable backwards compatible release. In general, most of the security fixes don't break backwards compatibility anyways. It's usually another line of code where just an extra check is introduced. So the next funny thing, or not so funny, on if you're on the inside, is confirming the fix. Basically, we will provide you with the patch that we have, and we'll ask you to confirm that your issue is fixed by our patch, or if you provided the patch, we will try to confirm your patch and reproduce it. This part is really, really important because we generally have had some issues with patches in the sense that, for instance, with host header validation from the initial report to an actual fix, we needed, I think, 3 or 4 security releases because we tried a blacklist first and went to a whitelist in the end, which we should have done in the first place. But while we don't want to rush security releases, we want to take our time to fix the issue properly. On the other hand, we don't always have the best fix in the first iteration. This also happened with our password hashing, which was technically correct, but the code was way slower than it should be, which resulted in another denial of service attack. But at least the hashing was correct, which is good.
All right, now that the patch is confirmed, that we have something that is ready, let's get it out there. Well, not quite yet. We can't just push a security fix because that would be kind of unfortunate for a lot of people. So what we do is we notify a few people or a few key organizations beforehand that there will be a security release, and this announcement is going to on a public mailing list, for example, the Django announce mailing list. But Django is not only distributed by the Django Software Foundation itself, it's also being distributed by operating system vendors, and it's being used by huge organizations that would have a massive impact on security issues in Django if they won't be fixed beforehand. So these two parties will get informations beforehand which are more detailed on what the issue is, so they can potentially provide fixes on their internal Django versions. If you are writing a third-party application that is directly affected by the security problem, and it's a well-established project, and you have a proven track record with the Django community, we likely include you in this announcement as well, or in the pre-notification. And now that we have this pre-notification out, we can actually start preparing a release. And this means approximately 1 week after we send out this pre-notification, these patches or these fixes we have are going to be committed to the master branch and all the related branches that need to be updated. And at this particular moment, the security issue is considered to be made public and has been disclosed. Because you can look at the repository, you can see this patch, and you can potentially come up with an exploit and start attacking other people's websites. Following this commit to the release branches, somebody from the release team is going to cut a Django release, is going to upload that to our servers, to PyPI, and then as a follow-up of that, we have the announcement, which is then made official, like properly officially public, which means is going to be a mail to the Django announce, Django developers, Django users, mailing lists, and also the OSS security open wall list. Together with that, and together with the announcement, we're going to publish a blog post with a bit more detailed information on what we have in the email. And one of the information we have in there are so-called current vulnerability and exposure numbers, or CVE numbers. They are pretty important if you don't use Django from PyPI, for example, but use a operating system vendor provided one, because you can use those versions or those numbers to check if the version you are using or the version that the operating system vendor is providing you has been fixed with this issue. And if you look at Linux systems, Linux distributions out there, they, like Ubuntu, for example, they won't just update to the next major Django version just because there's a security release, but they will backport certain patches to their currently version. So speaking of all those security things, there's also coming up in the last couple of years a thing called bounties. And the Django project is pretty lucky in being able to pay out bounties for security report or for security patches. Though we don't actually pay for those bounties ourselves, we have organizations or companies more so that pay for them. And if you use HackerOne, for example, to report a security issue, then the bounty is going to be paid by Microsoft and Facebook, which you might want to say what you want, but they actually do put money into open source. Another project or another program Django is participating in is the Google Security Patches Rewards program, which requires a release with a patch that improves security in Django. So when you take a few steps back, and we were talking about if you want to provide a patch or we build our own patch for Django, if you provide a patch, you can apply for, yourself for on the Google Security Rewards program and ask them for some rewards given that you provided the patch and the Django release was issued. And depending on the severity of the issue, this can be like $500 to $1,500 US dollars. All right, let's look at Django's history. This is where the fun starts. When you open the Django project website, this is one of the first things you see. Reassuringly secure. Django takes security seriously and helps developers avoid many common security mistakes. Great. And because we try to help you not making them, we apparently do them ourselves.
So I have a small confession to make. I like numbers and more specifically statistics. And Mark Twain used to say that there are lies, damned lies, and statistics, so we have to go over those numbers. What you're seeing here is the number of CVEs we've issued since we've started our security process. What does it mean? Ignoring 2017 for now, because I think we will reach the same level as 2016, because we are probably going to get a few other security issues we don't know of yet. It looks as if Django is getting worse, right? I mean, we are having more and more security issues every year. It's not as bad as it could be, but it's certainly a trend is visible there. While this is true, obviously, from the raw numbers, we have to take into account that since Django started, the web shifted quite a bit. 10 years ago, SQL injection was quite common everywhere. Nowadays, you use ORMs or anything to guard you against that, and the actual attacks get way more complex, even in the sense that 10 years ago many people didn't even bother looking for attacks, or most websites weren't a viable target. Since Django is powering sites like Instagram and discuss, it's obviously quite important that we take security seriously, so I wouldn't really take those raw numbers as indication that we are doing bad. What's more interesting is the classification of our vulnerabilities. What you see here on position 1 is DOS, denial of service attacks, which, while are annoying, is something you can usually easily work around. Our main focus is usually against cross-site scripting or cross-site request forgery or code execution. Site being down is in general not as bad as losing your credit card data, which you hopefully are not storing anyways. Aside from that, so cross-site scripting XSS is number 2, together with denial of service attacks, is roughly the half of all the attacks you are going to see, which means in your own code you probably want to look out for those as well. Given those categories, we want to give a short, really short overview because we have like 5 minutes left. Just a few buzzwords, what you should look out for that you can further look into your own code. So cross-site scripting. Nice example, use your data, throw it through JSON and mark it as safe. This is not safe in any sense. The templating language doesn't help you there anymore and you can easily break out of the sandbox. So to make this safe, you have actually 2 options. One would be to use the proper functions like escape.js and use that inside the JavaScript string, which is the only safe way. What's important here to take away is that while all of this is inside HTML, different context does apply on whether you are inside a JavaScript string, inside a script tag, or inside a normal HTML block. So if you can't do that because you have content security policies, which is something else you want to look into, just put the JSON serialized data as data attribute into your HTML, and then you can directly access that with jQuery. No chance of any execution. Another thing here is cross-site request forgery, which basically is the idea that someone uses your browser to make requests to another homepage. In that sense, I'm trying with an image link to transfer money from your bank. This should obviously not work, and in general you would use a POST request and not a GET request, because GET shouldn't modify state anyways, but it serves as a nice example. Denial of service attacks. We had quite a few of those, and so one of them was in the Python XML libraries, which led to a package called diffused XML, which you should install if you are using XML anywhere, because as far as I know, this issue isn't fixed in Python itself. And this was also one of those circumstances where Django was pre-notified from Python and other communities, in the sense that, hey, this will require worldwide coordination basically, and we need to fix this together. And luckily we fixed it and didn't rely on Python fixing it, because they are usually slower and have a hard time updating all the system packages and whatnot. Also, the usual stuff applies, like don't ever call an external service inside your request loop, because if the external service is under user control, they can just like not return any data or return it byte-wise over a minute or so and basically block up your worker process. This is all falling under denial of service attacks. And I think I'll hand over to Markus.
So the next thing that's quite common, to be honest, are unvalidated redirects, and the last Django release was one of those that fixed another issue in one of the methods we have to protect against that. The method is called isSelfURL and was like 4-time offender now. So like you see, this is hard, and don't try to do that yourself. What the actual issue is the parameter, or the value for the next parameter there, can be user supplied, and when you try to log in and you redirect the user to that site and they don't take care of where they actually land after a successful login, then well, this is gold for a phishing site, and you have your first victims on your phishing site and can scrape their credit card numbers or whatnot. Florian already mentioned header poisoning earlier, where that was where we broke 1.4.4 and required the allow hosts setting, which everybody is annoyed about, myself included, but this is pretty much the only way you can prevent that. And if you don't do that, the way Django constructs, for example, absolute URLs you could use in emails, they come from, the host comes from this host header string. And if an attacker can inject something in there, in the context of a different user, for example, then, well, you got your phishing link again, because then the email contains some other domain that is not yours, potentially. We mentioned remote code execution. Pickle is a really fun thing if you want to be vulnerable. So if there's any chance of not using Pickle, instead use JSON or something else, then that might be a good idea. There was an issue it wasn't recently, it was in 2014, where it was fairly hard to trigger. You could potentially import modules that then ran code, but yeah, I said it was rather hard to trigger. Then there's authentication and authorization failures. Like if you forgot the login required there, then, well, this is kind of unfortunate because suddenly your entire user database is empty, because I can just call that with an arbitrary user ID and that user is deleted. Directory traversals are fun. Like, please load this, let a user define a string to a file, and then just open this file and put it out, give it the content. So if a user then enters like these ... they could potentially end up at your etc passwd or their settings.py, which then exposes your database credentials. And with those, you probably can have access to the whole database server, and yeah, I think at that moment you lost. And then the last one we want to talk about that was on the diagram before are information leakages, which essentially mean that every time an attacker gains access to information they probably shouldn't have, it's not really what you want. And this can pretty much reach from this username exists or does not exist versus up until here's all the data we know about a certain user. So things like returning HTTP 404 versus HTTP 403, so not found versus access denied, can make a difference in how an attacker treats your API, for example. And yeah, this is something you probably want to look into. Now, having all those things up on the side, this was a lot of content in a short amount of time. The thing you probably want to look into and want to remember is OWASP. It's what's called Open Web Application Security Project. They provide a top 10 list of issues that is common in, well, web applications. Even if it's slightly business focused and not necessarily super technical, it provides a whole bunch of keywords you can look for. And we really recommend to look at it, go through that, not necessarily read all the articles there, because that's a whole lot of content, but like go there and have a look and see if, like, pick some things that that sounds interesting to you, and then look in your own projects for them and try to fix those. All right, thank you.